Okay, hello. So we meet in this supplementary video. I guess I should thank you for your curiosity that you wanted to know how the clamper circuit works. Okay, so let's get started. The working principle is actually quite simple. It is similar to the clipper circuit with some minor adjustments. So let me draw the clamper first. I have my input signal. I have my capacitor. And I have a diode, okay, and I have my voltage source. Okay. Yeah, that's about it. Alright, so how does this circuit work? Let me first input a voltage to the circuit. I will input this voltage. Okay, this is 10 sine omega t. Alright, so first of all, what happens is that initially when you first run this circuit, okay, you have attached a capacitor. Initially the capacitor does not contain any charge. Okay, suppose it doesn't contain any charge, so it has zero charge. So if a capacitor has zero charge, do you know the relation between the voltage of a capacitor and its charge? Okay, do you know that? So let me just write that down. That is Q equals CV. Okay, all right. So if the capacitor is uncharged, it doesn't contain any charge, so this Q is 0. All right, so if this Q is 0, what is the value of V? The value of V will also be 0. Okay, so I have a device that the voltage across the device is 0. Do you know what it will act as? Okay, a device that has 0 voltage across it, what does that act like? Okay, so that is actually a short circuit. All right, a short circuit has 0 voltage across it. Short circuit VD equals 0. Okay, this plus minus VD. Okay, so if it acts as a short circuit, well, this point will be directly connected to this point. This point will be directly connected to this point, and suppose my voltage is rising, so this diode will start to conduct. Okay, this diode will turn on, and if this diode turns on, current will start to flow in this direction. Okay, current will start to flow in this direction. Sorry. Okay, so if current starts to flow, then I have current in this direction, charge will start to flow, and slowly but surely charge will start to accumulate inside this capacitor. Okay, charge will start to accumulate inside this capacitor. This terminal will have positive and this will have negative. Okay, all right. So can you tell me what is the maximum voltage? What is the maximum voltage that the capacitor can charge to? You see the input is rising slowly. Okay, the input is rising, and as the input voltage is rising, the voltage across the capacitor is also rising. So when the input will reach its maximum point, its maximum voltage, the capacitor will also reach its maximum voltage. What will be that voltage? Okay, you see what is the maximum input voltage? The maximum input voltage is plus 10 volt. Oh, oops, I perhaps need to have added a voltage here. Suppose this is 2 volt as we used in our examples. Okay, so the maximum input voltage is 10 volt. Among from this 10 volt, 2 volt will be consumed by this voltage source. Okay, this voltage source will take up 2 volt. So the remaining, definitely the remaining voltage source will be left for the capacitor. Okay, So what is the maximum voltage that the capacitor can charge to? The maximum voltage that the capacitor can charge to is 8 volt, right? Simple enough. Okay, so now what happens? Now suppose now the input voltage starts to go down. Okay, input voltage starts to go down in this direction. From 10 volts, suppose the input voltage comes to plus 9 volt. All right, so what is if the input voltage is at plus 9 volt, okay, if the input voltage comes to plus 9 volt, and if the capacitor is at plus 8 volt, will this diode turn on? Can you tell me? So for this diode to turn on, what is the voltage difference between the anode and the cathode? Let's figure that out. What is the voltage of this point? If this point is at ground, what is the voltage of this point? This point will be at 2 volt, right? Now what is the voltage of this point? Okay, if this voltage is plus 9 volt and this voltage is plus 8 volt, okay, this voltage is plus 8 volt, what is the point of this voltage? Okay, you can just use KVL, or I like to figure it out, like if this point is the ground and if this voltage is 9 volt, then the voltage of this node is plus 9 volt. And since this terminal is the positive terminal of the capacitor and this terminal is the negative terminal of the capacitor, that means if I go from this node to this node, the voltage will decrease. By how much will it decrease? It will decrease by 8 volts. Okay, so the voltage of this node will be 1 volt. Okay, or you could just use KVL, I guess. I mean, you have one voltage source that is at 9 volt and another voltage source that is at 8 volt. Okay, so what will be this voltage? Just do a KVL loop here, KVL, and you can write minus 9 plus 8. If I give this a name, V0 plus V0 equals 0, then V0 equals 1. Okay, simple enough, 1 volt. All right, so if this node is at 1 volt and this node is at 2 volt, will the diode turn on? Can you tell me? The anode is at 1 volt and the cathode is at 2 volt. Well, the diode will not turn on. All right, because for a diode to turn on, the voltage of the anode needs to be greater than the voltage of the cathode. Okay, so the diode will remain off. What happens if the voltage of the input goes even lower? Okay, suppose the voltage of the input goes at plus 8 volt, then what will be this voltage? The voltage of this node. This will be then at 0 volt, because our voltage, we are finding this voltage as V0 equals to V in minus 8. 8 was the voltage at which our capacitor was charged. Then this will go to the 0 volt. Will this diode turn on at 0 volt? Well, it will not. If the input voltage goes lower, well, it will still not turn on. Okay, so for all voltages below 10 volt, this diode will remain off. Actually, well, in fact, since 10 volt is the maximum voltage, all voltages of the signal are actually below 10 volt, right? So this diode will never turn on. Okay, no matter what voltage the input goes to after the capacitor has stopped charging, this diode will never turn on. Okay, this diode will remain off forever. Off forever, I mean after the capacitor has finished charging. Until the capacitor is charging, during that time the diode will remain on, but after that it will become off forever. So if it becomes off, then what will this diode act as? It will act as an open circuit. So let me just draw the circuit again using the open circuit, replacing the diode for an open circuit. So I have a voltage source here and a capacitor here. Okay, and my diode is off, so it is an open circuit, and I have voltage source here. All right, okay, so this was 10 sine omega t, and this was plus minus 8 volt. Okay, and this is the output port. So if this remains off forever, then this voltage source can no longer affect any part of the output. Okay, so we don't need to consider this voltage source anymore. So now what will be the output voltage? Can you tell what will be the output voltage? Well, as long as since the diode will never turn on, the capacitor can never discharge. Okay, since the capacitor can never discharge, this capacitor will act just like a voltage source. Okay, this capacitor will be exactly equivalent to a voltage source. Okay, so what will be the output voltage? If I apply KVL like previously, then the output voltage will be just V in minus 8 volt, since the capacitor has been charged to 8 volt. So V in is 10 sine omega t, so I can write the output voltage as 10 sine omega t minus 8. So what will the graph of this output look like? Well, we can see from this equation that the output will be 10 sine omega t, but the 10 sine omega t graph will be shifted downwards by 8 volt. Okay, but this is actually the same graph that we saw earlier. You see our original graph that had shifted downwards by 8 volt. What happened to this graph? Well, the upper peak was shifted to 2 volt, right? The upper peak was shifted to 2 volt. So what this circuit actually does is it shifts the upper peak of the input voltage to 2 volt, and that is what a negative clamper does. Okay, simple as that. So you can just carry out the same argument if I reverse the diode and find out the workings of the positive clamper. Okay, exactly same argument, just the only difference now will be if the diode is shifted. Okay, if I shift the diode, then current will flow in this direction. Okay, if I shift the diode, if I connect the diode upwards, the current will flow in this direction, and in this case this terminal, okay, this terminal will be the positive terminal of the capacitor, this terminal will be the positive terminal, and this terminal will be the negative terminal, because, well, the current is flowing in the opposite direction, right? And all the other arguments will be the same, and in case of V in minus 8, we will probably get V in plus something, perhaps we will not get 8, we will get something else. Okay, so I said in the video lecture one thing, that you can never shift a signal upwards by using a negative clamper. Okay, by shifting the signal upwards means if I connected a voltage source of 20 volt in this place, does that mean that the upper peak will be shifted to plus 20 volts? Well, no. Why no? Can you guess? Well, see here that if I connect a voltage of 20 volt, what will be the voltage of this node? Okay, what will be the voltage of this node? The voltage of this node will be 20 volt. But what is the maximum voltage of this node? The maximum voltage is 10 volt. Okay, so the maximum voltage of the anode will be at 10 volt, and the cathode will always be at 20 volt. If this is so, well, you can see that the anode is connected to a lower voltage than the cathode. Will the anode turn on? Sorry, will the diode turn on anytime? Well, the diode will never turn on. So if the diode never turns on, then this capacitor cannot charge. Okay, for the previous example, we saw that the diode at least has to turn on for the capacitor to charge. Okay, after that the diode can turn off. But if the diode even doesn't turn on for the capacitor to charge, will the clamper circuit work? Well, it will not work. Okay, so for a negative clamper, if you connect a voltage that is higher than the maximum voltage of the input, then the clamper will not work. And if that doesn't work, that means that you cannot shift a signal upwards by using a negative clamper. Similarly, For a positive clamper, if you connect a voltage source that is lower than the negative peak of the input, here the negative peak is minus 10 volt, and if you connect a voltage that is lower than minus 10 volt, suppose you connect a voltage that is minus 20 volt, then also the clamper will not work. The reasoning is exactly similar. Okay, so since the clamper will not work, that means that if we use a positive clamper, by using a positive clamper we can never bring a signal down. Using a negative clamper we can never bring a signal up. All right, we can never bring a signal up, and using a positive clamper we can never bring a signal down. Okay, so if the clamper doesn't work, then in that case what will be the output? Well, the output, since the capacitor doesn't charge, then the voltage across the capacitor will be permanently 0, and the capacitor will act like a short circuit. So the output will be exactly equal to the input. There will be no shifting. Okay, for these two cases there will be no shifting of the input voltage, and the output will be just equal to the input. Okay, no change will happen to the input voltage. Why? Because if the capacitor is at 0 voltage, then what will be the circuit? What will the circuit look like? The circuit will look like this. Okay, capacitor is at 0 voltage, so it will act like a short circuit, and the diode will never turn on, so that diode will act like an open circuit, and I will have a voltage source here. Okay, so what does the output look like? Well, the output is short. You see, this portion is short with the input, so the output will be exactly equal to the input. Okay, so that was our explanation for why a clamper circuit works like the way it does. So this is officially the end of your diode section of the syllabus, and this will be included in your midterms. And after the midterms we will talk about amplifiers and operational op-amps and transistors and all that. Okay, so best of luck for your midterm. Hopefully I was able to make you understand some of these concepts, and if you have any confusion, I guess we could talk in the consultation session as well. Okay, so hopefully you enjoyed the video, and I will see you after the midterms. Well, at least in the video lectures. I will definitely see you in the consultation sessions. Okay, thank you everyone. Bye bye.